This is section 2.4, measures of central tendency. Almost done here with chapter 2. Just got a few more here to wrap this up. But this part here from 2.4, 2.5 and 2.6 are going to start looking at our first look at statistics. So going back to chapter 1, a statistic is a number that represents the sample. So all these examples are going to be samples. We're going to do something with those, either numbers or non-numbers, like categorical data, that qualitative data. So naturally, a lot of these are going to be numbers, but they don't have to be. Anything goes here. We're going to use these concepts to find the center number. For this first example, I'm going to start off with these few numbers here, and we're going to figure out each one of the following down here, starting off with the mean. So we'll just outline what I mean by these concepts. What's the mean, median, mid-range, and mode? And again, these are just an example up here dealing with numbers, but we can also do something similar if we don't have numbers. So we'll do that. We'll start talking about symbols, and down here at the bottom addressing those things before we move forward into further examples. Okay, so here the center of a data set, what is in the middle? That's what we're looking at here. And so we have 4 ways to evaluate and say this is the middle number. When you have a closed set, or possibly we wouldn't have an infinite set, that would be impossible to do. Well, in a statistical sense it would be impossible, but with an obtainable set of numbers, anything goes. What affects them? Why are they relatively the same, or they're not the same? Not all of these are going to agree about being the center number. So then the discrepancy goes with, and we'll look at this in the further examples here, which one of those that we are going to go with. But for all purposes here, for like quizzes, test questions, I will ask you, please let me know what the mean, median, mid-range, or mode are for a particular set here. So we'll start off with this basic one here, and this one. Looking at these, looks like here we've got 1, 2, 3, 4, 5, 6, 7 numbers. Out of those 7 numbers, the first one is what is the mean, or what is the center number. Is kind of the the above theme there for this section. So the definition of the mean says to add them all up and divide by the number of values that we have, and that's what's noted up here. That it says in other words, the words mean and average are used interchangeably. Absolutely true. They mean the same thing. But I suppose you could see the common thread is that all of these start off with the letter M, meaning the middle. So more technically, the word mean is referred to as the arithmetic mean. There is a geometric mean that's completely different than this, and that's why it's called more precisely arithmetic mean. And it is just that. It's the average. It's adding them all up and dividing by the number of values that we have. So for the mean here, what I'm going to do, I'm going to take the 21 plus the 22 plus the 23. In other words, I want to add all of these together, plus the 25 plus the 26 and the 27, and then divide those by 7. And again, that's because we have 7 numbers. So then divide by the number of values in the sample, otherwise known as the sample size. So I can come over here and call the 7 the letter N. The letter N in the alphabet is a statistic, and it stands for the sample size. Again, that is the number of values in the sample set there. So to always divide by the sample size. All right, let's go ahead and add those numbers up, 21 through 27. Let's get a total and then divide by 7. So grabbing a calculator here, I'm going to take the first one, which is 21, plus 22, plus 23, plus 24, plus 25, plus 26, plus 27, and then we get 168. So therefore, our answer is 168 divided by 7. Let me do that one more time here. And grab and divide by 7. And then we get 24. Therefore, using for the mean, the center is, in its perspective, is the number 24. The next one, the median. So what I'm trying to do, this is just an introductory exercise for the rest that's happening here. But for the median is also measure the center. But of course here for the first step, make sure that we order the data. Order data first. You'll need to do this in section 2.6 as well, but I can't emphasize enough on the importance of ordering the data, because without that you get this wrong. So let me present this idea up here. So the median is the center number. So what number is in the center? You can see here that the number is 24, and that's because there are 3 values above it and 3 values below it. It's directly in the middle. So there's not necessarily an algorithm associated with the median, but it directs you to the middle value. If I didn't have 7 numbers, say that I had 6, you would have to average the middle 2 in order to attain the median. But of course, all's a wash if we don't have that in order. Next one for the mid-range, this is always the average, or basically here it's the max. Actually, let me back up here. It's not but the minimum plus the maximum divided by 2. That's the definition of mid-range. Min plus the max divided by 2. Not to be confused with the range though. Something kind of like a midpoint. If I wanted to find the midpoint of a class, I take the lower plus the upper limit, divide that by 2. So I want to do that here for this example. I'm going to take 21, which is the min, plus 27, and then you divide that by 2. Let's do that. So 21 plus 27 is 48, and then divide that by 2. There you go again, you get the number 24. So great. They all kind of agree here that the number is 24. However, for the last one here, for the mode, this is the value, this is the number in the sample that repeats the most. Since in this case nothing repeats or all have a frequency of 1, then the mode does not exist. So that's unfortunate, but of course we only have a few numbers up there to play with. If we had certainly a lot more numbers, the mode should appear here. Of course, I picked a set that was consecutive, so any consecutive numbers that you have like this or integers are not going to display a mode. So we'll get into more of that stuff later. Let me come down here at the bottom and talk about a little bit about notation. And this is crucial here, that there is a notation for a lot of things that we do, like the value n. And we learned that starting off with this, that the letter n is a symbol that stands for the sample mean. But there's 2 different types of means. There is what we call a population mean or a sample mean, and they're very different from one another. The population mean is represented with the Greek letter mu. It's a lowercase Greek letter, but it's spelled mu. And then for coming from the sample itself, more often not, we're finding x bars. This is called, I guess, x bar, spelled that way. And the bar simply means to take an average of the x values. So anytime you have a bar above a variable, it means to average all of those numbers. So simply in this case, since x represents, or a variable x is a number representing from our sample, then the bar above that number, or above that letter, that variable, says to average all those. In other words, add them up and divide by the number of values in the set. But of course, there's no distinction here, but the difference between these, that the formula that you use to find the population mean is exactly the same formula that you use to find the sample mean. The only difference is that the population mean should represent a lot more numbers than the sample. So this is just an introduction to what's to come ahead here in section 2.4, but all this entails finding the center number for a data set, for something that's probably not in order, or it could be in terms of a frequency distribution, which tied into what we used back in 2.1 and 2.3. Those were frequency distributions were used to make graphs, but they can also be used to find the mean. So we're going to continue with those concepts here in this section in 2.4.